So, so if we can characterize how this inductance part and the capacitance part can be changed through GANs and through materials and also dimensions. And this will require a little bit of work. And Tony from Japan, I saw the Facebook, and it was in the last cosmic reactor groups. I mean, there was I think Sandor talked about it. Remember that this Japanese guy, his name is Tony, he characterized capacitance using different GANs and some material, different material, right?
Right, yeah.
So that's one aspect of this characterization of capacitance. There are some electrical engineers involved with me as well. I myself is one. And we are looking into doing some characterization along some other dimensions of capacitance, like if you put feedback, which is one of the types that was introduced, split capacitor, early on by Mr. Kesh, which wasn't investigated a whole lot. I did a little bit of some of these things, and it was it definitely the power. I mean, with the hand, you can feel that there is a difference in power if you do the feedback. But beyond that, we didn't have any measurement. But now with Tony's approach of adding known capacitor value so that you can better characterize the unknown part. So this is something it will require a bit of work, but it's worth investigating, and it may also lead to figuring out what are the different frequencies or pulsing that we can generate from changing various properties of these capacitors.
Mm-hmm. Yes.
Does it make sense, or am I too fast?
No, made sense to me. What about you, Mark? Does that ring a bell?
Left field for me. It rings no bell for me. I'm sorry. You know.
Do you have any question?
I have a ton of questions because in a capacitor, when, I don't know anything about a capacitor, but in a capacitor that I've just learned about, the acid that's in the capacitor, like Rick said, one is a magnetical, one is a gravitational, but what separates that field? I mean, what keeps those, or are we just having those two elements together so that they are atomically moving in one container? You know what I'm saying? So you put the zinc in the, like the Baghdad battery, they just have a zinc, copper, and salt in a vase, in a vase, and it gives you a battery. So, I mean, is that a capacitor? Because it's allowing the ions in that space to hold or create motion between the copper and the zinc in that container.
Generally, in a battery condition, it's more of a chemical process. In terms of ordinary science, at least, it would be considered a chemical process, not like an inductor or a capacitor, which is basically the storage of charge on a surface or in a magnetic field.
Where does the separation come from, though?
The separation in the battery, you mean?
Or what you're just explaining. Where does that, in the capacitor, where is that?
Okay, well, let's look at it. Let's do maybe a whiteboard on it and see if we can draw it a little bit. Okay, let me just get this set up here.
I'm sorry, because
this is a good question that lots of people do have, so maybe we can explain it out a little bit.
Because in the capacitor, in Mr. Kesh's capacitor, you have from inner to outer, you have a copper wire with the insulation of the wire, and then you put the GANs on the outside of that wire. Then you wrap it with a non-flammable tissue, like parchment paper or whatever, and then you have another zinc or foil. Some people were putting zinc and foil, and then they were wrapping it with two coils, one feeding back, or the five, like.
Yeah, it's starting to get really complicated there without looking at an actual drawing. But let's start out with something very simple, like if we look at just a regular coil that we are used to dealing with. Then if we were to have if we were to have, say, a plus and minus or a potential on either end of that coil, then it'll create a magnetic field. And that magnetic field contains the current in a in a field. It'll store that current essentially. Now, if you have a capacitor, a basic capacitor is composed of two plates, let's say, and you could even look at it more three-dimensionally if you look at it like two plates that are close to each other. And so you have a wire attached to this plate, and you have a wire attached to this plate, and again you have a plus and minus condition, or a gradient basically between these two plates. So what happens is, if you were to hook up a battery to this circuit, you end up with, it charges the plates. So you get a bunch of plus charges on one plate, for example. And
are those two plates laying on top of each other with nothing in
well,
between?
Here's the deal. In a capacitor, the plates have to be separated and not touching each other, because that would allow the charge to equalize. And the whole idea with a capacitor or other circuits like that is to separate the charge, and that's what gives you the potential. Right? So if one plate receives a positive and one receives negative, or becomes positive and becomes negative, then it builds up the charge, and the charge will be continued to build up according to how far the plates are from each other for one specific kind of one variable is the distance there between the plates. The other variable is the size of the plates. So two bigger plates close to each other will have more of a charge, or can have more of a charge, can be charged up more than smaller plates that are the same distance from each other. In a similar way, the closer the plates are to each other, the more the charge, the more intensity of charge that can be built up. So you want them really close together and really large plates. So what they do normally is you take a foil and you wrap it up in a spiral, and you put it inside of a tube, and you hook up your wires to it and so on, and you can actually have make a capacitor as long as it doesn't all touch inside. So you need to have an electrolyte or a spacer in between these plates, and they might use plastic film, could work as a spacer, or you might have oil in between. For someone like Tesla, he had huge vats, big vats of oil,
What about that?
and had plates inside that were separated by the oil and so on, and he would have a huge charge built up in these capacitors that he built that were running his Tesla coils and so on. Sorry, what was the question there, Mark?
If he had something like that, could you get electrocuted from something like that?
Absolutely, yes. You can get electrocuted from You have like capacitors that look kind of like this, and they're kind of like hand-sized or whatever. microwave oven even. And they could even be just 250 volt or something like that. But you charge that up on its two terminals, and if you were to accidentally put your hand across it, it could kill you, because you have 250 volt at quite a few amps or milliamps depending, and enough to kill someone. So yes, capacitors can be very dangerous that way. That's why they often have a little resistor that's attached to the terminals. It's called a bleed resistor, and that bleed resistor will gradually, maybe over seconds or whatever, bleed down the voltage in a capacitor if it's in a certain circumstance where it is not supposed to remain charged up, because it could be a safety item and that kind of thing. A lot of motors will use a capacitor like this, a starting capacitor it's called. A big thing that looks like a huge battery, almost a metal canister like. And yeah, so there's all these different types of capacitors. They use capacitors in sound systems, and these fancy sound systems in cars that have big bass woofers, you know, that take a couple thousand watts and so on. You run a capacitor, and the capacitor acts like a battery. It stores up the energy, but it can deliver it close to your system, to your amplifier that needs all that power. Instead of running huge big cables to the battery, you can run smaller cables and a large capacitor close to the amplifier, and whenever the amplifier needs a little bit of extra oomph, it draws from this capacitor, because it's more or less instant energy that can be delivered through a capacitor compared to a battery. Because the capacitor has the charge stored on plates, or in a similar manner, it can be more or less instantly discharged within a second or two or three, compared to a battery, which would maybe take an hour to have an orderly discharge, or half hour or something like that, say, without overheating and frying itself.
Would you have a discharge from a nano-coated plate to a non-nano-coated plate?
Well, that's a good question, and there's still a lot of work that needs to be done with nano-coated plates to see, you know, say if this was nano and the one underneath was non-nano, would that make a difference? I don't really know. I think it would. I know that the nano-coated plate, you know, it has that surface resistance. So in effect, I think that it would be possible to take for example, two nano-coated plates, or a nano and non-nano-coated, and put them right together, and technically there shouldn't be any interchange of the they shouldn't short out, because of the nano layers are very, very high resistance, and there shouldn't be any interchange between the non-nano-coated and the nano-coated plate, even if they're put directly together, unless the nano-coating wasn't quite correct. So, but that still needs to be tested and see. Say again?
You know what I'm saying? So now that you know what you're saying, exactly what you're saying there, in the same idea as a capacitor, if they were together like that, non-nano-coated and nano-coated, where would the action be, or would there be action? You know what
Well,
I'm saying?
see, the thing with the capacitor is you still have the fields in between. There's always there's this tension or gradient between this plate with all of its charge and the other plate with this charge, and so it's a sort of like two magnets, a positive pole and negative pole.
The nano-coated plate would be the positive charge. It would accept a positive charge.
I'm not clear on that. I thought that the nano, well, maybe it will accept positive, but I thought the nano is usually attached at least to the negative side of the battery.
Okay, so it should be flipped around.
If that would be the other way around, to look at it that way, I suppose.
Yep.
But I'm not sure. It may end up
Now,
just because it's attached to the negative side.
a raw copper wire would accept a positive charge. They do it all the time, right?
A raw copper wire.
Right.
Well, in a different way, like this, say this coil at the top here, say that was a copper wire, it accepts a charge even if it's a straight wire. Let's say it's just a straight wire. You have, there's electrons and there's charge that moves through the wires. Electrons actually move, say, one way, and the charge moves the other way. The actual the field or the charge moves one way, and the electrons move the other way in the wire. Now the charge in the wire moves at basically the speed of light, but the electrons actually move very slowly. It could take an hour for the electrons to move along this length of wire, for example.
Well, don't they say that it stays on the outside of the wire, not the inside of the wire?
What stays?
Well, like the positive part of the wire is the external part, and the internal part of the wire is the E, which is going the opposite direction, would be the tubular effect of a copper wire.
That only applies in AC circuits, and it depended on the frequency. The higher the frequency, the closer to the surface the charge sits.
Yeah, I think it's on DC as well, though. For if it's a flow of DC current will still be on the outside of the wire, on the outer electrons, basically, of the wires, the way I understand it.
On the outside.
We're talking about the charge or the field effect, but the actual movement of particles will be the electrons, which will move in the opposite direction.
Which would be away from the higher, well, it's getting away from the magnetical, which is, like it's a separation. So the heavier parts move away from the lighter parts, which move energy in towards the field, which would be your cores or your magravs or your everything that is internal. That's the whole thing I'm trying to think about right now is what comes from the outside to the inside. What's popping my thinking right now. It's from out, because I have a copper nano-coated wire on an inside hollow tube, and now what do I fill that hollow tube? Because I'm going to bring external elements from with the nano-coated wire into I want to pull something into that tube, and that's why I keep thinking that CH3 pulls into the tube. Once that gets inside the tube, it's a live wire with CH3, and as it goes through the tube with the nano wire and the CH3, if there was something on the outside of that, which is my copper wire, if I put a CO2 or even all these other exotic gases that people are starting to make now, if that was on the outside of the rings, the copper nano-coated rings, as the energy goes through the inside, it's pulling all that to the inside and moving it to the outside. You know what I'm saying? It now creates that flow. That's my intention with the hollow tube, and my hope is that the CH3 is the heaviest part. I never wanted to use lead on the inside of any of these tubes because it's harmful. But now I'm learning that all these everything else that we've made is an oxide, which is outside. Oxide outside, CO2 outside, CuO outside, CH3 inside as a not an oxide, but it's the only thing we make that is not an am I saying that right? An oxide?
Well, that's a good point. Yeah, I guess so. But the actual movement of particles will be the electrons, which will move in the opposite direction. So the electrons will move in the opposite direction. Yeah, I guess so. So I've heard you keep saying that as a receiver, but I think of the CH3 as a giver more than a receiver. It's giving the hydrogens is the way I look at it. But any
Does
input on that?
make hydrogen?
You're correct, Rick.
So it's
CH3
like,
is
but
a giver.
I mean, you can still use it. The way I understand it's used in the outer, like in the example of a tube and a wire inside. Maybe could be used on the tube. You put the CH3 on the outer, and it essentially feeds the inner. Feeds the inner. I'm not clear on that actual, process, whether the hydrogens actually separate and end up interacting somehow in this, or if it's just the fields are enough to have the CH3 fields and have those, the three hydrogens. They're like little tails, basically, attached to the carbon, and they end up connecting with things and being useful. You could, break one off or break two or three off and use them. All of a sudden, you have a hydrogen ion ready to be used, and so on. So, but what's in between here, between the wire and the tube? That's a good question as well. Now we know we're getting some traffic going on or something there in the background. We know that a wire, for example, will have a field around it. So the wire will have a particular field all around it, and the same with the tube. The tube will have a field, and it'll have a different inner field than an outer field, and so on. And so what might be happening between the wire in the center and the tube? Is it like an air atmosphere environment inside, or maybe there's some sort of goo that we put in that's a GANS goo or some other substance, metallic substances and so on, as a dielectric or as a conductor that might influence that environment. There's different ways of looking at that, and lots of different combinations that people have used in that environment as well. And also another way to look at it is, what if we created a vacuum inside here and didn't put anything inside? Perhaps that would be a way to go, because maybe that would be much more close to the way the universe works. I mean, go outside of our atmosphere, it's nearly a perfect vacuum in the rest of space, and that's where all the action is, really, in that environment. Maybe that's what the environment we should be creating. We haven't really experimented much with a simple vacuum environment with these structures.
Can I share a quick picture, Rick?
Pardon me?
Can I share a quick picture?
Sure, yes, please.
You have to stop, okay? You see that?
Yes.
Okay, so what we did in this particular case was we put, this is nano coated on the inside, and we put, I think we put the oxides on the inside. Or no, excuse me, we put the CH3 on the inside, and we put the oxides on the outside. So we have nano-coated inside and this nano-coated outside. And we tried to put them in this delta configuration to try to amplify some of the power. But this is kind of what you were talking about a little.
Yeah, very much.
So when you nano-coat the inside with the GANS material, you're taking those fields, radiating those outward, and you're radiating them out even more when you have these nano-coated wires and put GaN's material on those. So it's like you're amplifying out and then you're amplifying out again.
Interesting. So, but it's
We use these things as power boosters, is what I call them.
are they sealed tubes? They have a cap on each end.
A cap on each end. These
Okay.
half-inch copper pipe.
And
Cap on each end.
soldered on. They look like they're soldered on or whatever. I think
Soldered
they're,
them, yeah.
yeah.